So as part of the upgrades to Terry with ROS 2, moving from Arduinos to Raspberry Pi Picos and micro ROS, I decided that I'd finally put a position sensor in on the pan tilt. So normally I was just driving one of these motors to do the panning, but with a position sensor I'd be able to find out exactly where things were at all times. So I was going to use one of these AS5048A magnetic rotary encoders, which basically gives you a 14-bit angular position sensor. And there's the chip itself. The motor did just have a small plastic base on it, so I decided to cut off the centre part of that and see what was behind it, which gives a brass bushing, and there's a tiny little bit of the initial drive shaft that you can get to. So from there I spent a few attempts trying to epoxy this magnet on, and as you can see it's not dead centre at the moment, but I thought I'd run an experiment to see how well the rotary encoder handled this suboptimal sort of arrangement that I've created, and it turns out it does it quite well. One of the problems there is the magnet is attracted to the motor and wants to rotate around and actually go for the plastic base, so you have to hold the magnet quite firmly, apply a small dab of epoxy to the top of the magnet, and then lower the motor into that just enough to get the drive shaft submerged in the epoxy, but not far enough to actually touch any of the brass bushing and bind the motor together. Otherwise you have to cut that epoxy off, or snap the magnet off and scrape all of the dried epoxy off and have another go at it. So this whole thing is being driven by the Raspberry Pi. Over here I've got one of the TB6612 H-bridge motors. There's the Pi itself, and that is monitoring with the setup I've got here. It monitors that every 30 milliseconds. The whole key being that you need to know which direction the motor is turning, and also take 2 readings from the HAL effect encoder per revolution, so that you can account for overflow and you don't miss any values. So with roughly 50 revolutions per 5 seconds, 30 milliseconds seems to work okay. At the moment the code's only accounting for a overflow in a positive direction, but there's always little things after you've just played around for a proof of concept. But at the moment the data values these are only published once every second, so the internal structure is updated every 30 milliseconds, and every second it gets published from the micro ROS. The results are fairly encouraging so far. Handy because I want to have the encoder at the base rather than at the top, and the only real, apart from the mechanics of actually getting the magnet attached, the main downside is making sure that the code is happy enough to execute at the drive shaft rather than the output. So you've got to work out what your ratios are and account for it, but it's all quite encouraging at the moment.